has long captivated the human imagination with its graceful appearance, seeming serene and almost dreamlike as it drifts through the sky, enshrouded in thick clouds that give it a gentle glow. This celestial body, bearing the name of the Roman goddess of love and beauty, seems fittingly picturesque at first glance. However, beneath this delicate exterior lies an environment that's anything but peaceful. The planet's surface is an extreme landscape, defined by blistering temperatures, intense volcanic activity, and a crushingly dense atmosphere. Venus is one of the most hazardous places in our solar system, and its corrosive, acidic clouds make exploration a formidable challenge. So, what have we learned about this fascinating yet hostile world? Surprisingly, quite a lot. Hi, you are watching the University of Universe channel. Join me as we delve into the characteristics and mysteries that make Venus such a unique planet in our solar neighborhood. Let's start by putting Venus in context within our solar system. Positioned as the second planet from the Sun, Venus is also Earth's closest planetary neighbor. Its average distance from the Sun is 0.72 astronomical units, AU, or approximately 108 million kilometers. Venus has an almost perfectly circular orbit, with minimal variation from this average distance, which makes it the least eccentric orbit among the planets. At its closest point to Earth, Venus is only 41 million kilometers away. However, this is not when Venus appears brightest in our sky. When it's closest, Venus lies between us and the Sun, presenting mostly its dark side to Earth. Even so, some light refracts through its thick atmosphere, allowing it to be faintly visible. Venus is actually at its brightest and it appears as a crescent in our sky and is the most radiant object after the Moon. This brightness has led to numerous mistaken sightings, including one by former U.S. President Jimmy Carter, who reported seeing an unidentified flying object in 1969, which was later suggested to be Venus. Venus also occasionally transits, or crosses, the Sun as seen from Earth, although these events are quite rare. Transits happen in pairs, with each pair separated by about 8 years, but a new pair only occurs roughly every century. The last transit happened in 2012, and the next one won't occur until 2117. This infrequency is due to Venus's orbital plane being slightly tilted relative to Earth's, combined with the fact that Venus catches up with Earth in its orbit only every 584 days. Like the other planets, Venus orbits the Sun in a counterclockwise direction. But unlike most other planets, Venus rotates clockwise on its axis in what's known as a retrograde rotation. Furthermore, it rotates at an exceptionally slow pace, completing one full rotation every 243 Earth days, making Venus's rotation the slowest in the solar system. Consequently, one sidereal day, the time it takes for Venus to complete one rotation relative to the stars, is actually longer than its year, which lasts 224 Earth days. Due to its retrograde rotation, though, a solar day, from one sunrise to the next, is only 117 Earth days. This means that a single Venusian year contains just under 2 days. The slow rotation results in Venus being one of the most spherical objects in the solar system, second only to the Sun. Scientists aren't entirely sure why Venus rotates in this unusual manner, but possible explanations include a massive impact with another object billions of years ago, tidal effects from the Sun, or tidal forces within Venus's dense atmosphere. Venus is often called Earth's twin because of its similar size and mass. It's a rocky planet like Earth, with a diameter of around 12,100 kilometers compared to Earth's 12,740 kilometers and a density of 5.3 g/cm superscript 3 versus Earth's 5.5 g/cm superscript 3. The gravity on Venus's surface is only slightly weaker than on Earth, about 8.9 meters per square second. However, that's where the similarities end. The Venusian atmosphere is vastly different from Earth's. With an atmospheric pressure 92 times that of Earth's, the pressure on Venus's surface is comparable to what you would experience 1 kilometer underwater on Earth. The density of the atmosphere, packed into a space just slightly smaller than Earth's, is mainly due to its composition, primarily carbon dioxide, with clouds of sulfur dioxide. This thick atmosphere creates the strongest greenhouse effect in the solar system, causing surface temperatures to soar to an average of 462 degrees Celsius (864 degrees Fahrenheit). In fact, Venus is hotter than Mercury, even though it's farther from the Sun and receives only 25% as much solar energy. Mercury lacks an atmosphere to retain heat, but Venus's atmosphere acts like a thermal blanket, trapping heat so effectively that temperatures barely fluctuate, remaining extreme even at night and near the poles. The winds on Venus vary dramatically depending on altitude. Near the surface, they're relatively slow, moving only a few kilometers per hour. But because of the atmosphere's density, these slow-moving winds exert significant force, moving small rocks and dust. At higher altitudes, winds become much faster, reaching speeds of up to 300 kilometers per hour in the upper cloud layers. These high-altitude winds sweep around the planet in as little as 4 to 5 Earth days, making the clouds appear to rotate much faster than the planet itself. The clouds on Venus are primarily composed of sulfuric acid, making Venus's atmosphere highly reflective, allowing only about 10% of sunlight to penetrate to the surface. These clouds also hide Venus's surface from visual observation, requiring radar to map the landscape. Occasionally, lightning has been detected in Venus's atmosphere, though it's less common than on Earth. At Venus's south pole, scientists have observed a large vortex, similar to those found on Saturn, although the two are quite different in shape. Intriguingly, at an altitude of around 50 kilometers, the pressure and temperature in Venus's atmosphere approach Earth-like conditions, though the air is filled with toxic gases. If we could build a floating, airtight structure, conditions at this level would be tolerable. The Soviet Venera missions in the 1960s to 1980s, we have actual photographs of Venus's surface. The Venera 7 mission, launched in 1970, was the first to successfully land on another planet and send back data, recording surface temperatures around 475 degrees Celsius (887 degrees Fahrenheit). Over subsequent missions, probes captured images of Venus's rocky terrain and collected data on its intense surface conditions. Using radar technology, we have mapped Venus's surface, revealing a landscape dominated by volcanic features. Venus is home to 167 volcanoes over 100 kilometers in diameter, with thousands of smaller volcanoes scattered across the planet. Although Venus's volcanic activity may not be as intense as Earth's, its surface remains largely unchanged, with no plate tectonics to renew it. Instead, scientists believe that Venus's surface was resurfaced in a global volcanic event around 300 to 600 million years ago, covering most of the planet with solidified lava. As a result, 80% of Venus's surface consists of volcanic plains. Venus has around 900 impact craters, each over 3 kilometers in diameter. Smaller meteorites tend to disintegrate in Venus's thick atmosphere before reaching the surface. Interestingly, Venus lacks a magnetic field, which puzzled scientists given its similarities to Earth in terms of size and composition. Some researchers have suggested that this might be due to the absence of a significant impact in Venus's history. Earth experienced a major collision early in its formation, which is thought to have contributed to the development of its magnetic field. Without such an event, Venus may have missed the conditions necessary to generate a similar field. Consequently, cosmic radiation interacts with Venus's upper atmosphere, producing lightning and an induced magnetic field. Solar winds also strip away particles from Venus's atmosphere, creating a tail that sometimes extends toward Earth when the two planets align. Unlike Earth, Venus lacks a magnetic field, possibly due to a different formation history, and as a result, solar winds interact directly with its atmosphere, stripping particles and creating a comet-like tail. Thanks for exploring Venus with me. If you found this journey through the solar system's morning star intriguing, I have many more videos exploring other planets and celestial phenomena in our solar neighborhood. Our solar system is full of wonders, and there's always more to discover. But for now, thanks again for watching and see you next time.